Hi everyone. In this Connect with Networking video, we're going to discuss Chapter 12, Network Management. Let's go ahead and get started. The task of network management is involved with processing how our networks operate, how we monitor their processes, and how we control the networks to make sure that they're working as intended to provide value to our users. So that's a very broad umbrella for the various people that work in the network management field to make sure that all of our devices and the hardware and the circuits that are connecting all those devices are working as they are meant to. Let's get into a few of the specific details that network management deals with. Operationally, network managers have to deal with what happens day to day with the network. So that would be dealing with things like providing technical support for users, making sure the network is operating reliably and providing the appropriate amount of bandwidth for the various devices, evaluating network hardware, software, and services, and when necessary, upgrading or purchasing new equipment to maintain the quality of the network, managing network and technical staff, and dealing with network budgets, typically with an emphasis on controlling costs. While the use of networking has increased over time, network managers have to deal with these increased needs with often stable or even decreasing budgets, which is obviously a challenge. Longer term, network managers have to deal with how their computer networking and voice communication networks meet with their organization's overall policies and goals. We've talked in earlier chapters about the convergence of data and voice communication. So network managers have to stay abreast of the latest technologies and make sure that they are taking full advantage of the best ways of approaching disparate parts of the network. They also need to make sure that they are dealing with the appropriate vendors and providers to get the overall best experience at the lowest cost for their organizations. They are also responsible for making sure that senior management understands the implications of network decisions. In many cases, the network decisions that network managers are making are highly technical, but they need to communicate those decisions to business managers that may not understand those technical details. So being able to translate from the technical to the business side of things is a critical aspect of a network manager's role. When designing networks in the first place to make sure that they are maintainable, it's important that we install devices that are easily manageable. And there are devices that are called managed devices that contain a host of features that allow for remote configuration and management. This does mean a higher initial investment for the network, but probably saves lots of money in the long term because remote management means you don't have to staff offices after hours. You can just manage hardware off-site when necessary. It also means that network managers can be notified when something's going on automatically, as opposed to having to manually check to see how the network is operating. Another way of managing and improving network performance is using device management software or point management software. This allows managers to monitor performance and the configuration of various devices on the network and make changes accordingly, so tweaking and tuning the network as things change and progress throughout a day or a week or in some sort of cyclical fashion. Networks also typically have system management software and application management software installed, which allows remote changing of operating systems and applications that are installed on various devices throughout the network. One of the protocols that allows all of this to happen is called the Simple Network Management Protocol, SNMP. It's installed on a variety of different network devices and then connected with various software agents so that you can manage those devices remotely. And all of the data that is collected from those devices as they report back their status and traffic levels and performance levels is stored in a management information base. SNMP allows you to manage devices on the fly, but also allows you to collect statistics over the long term to justify needed upgrades and repairs to the network. Pictorially, what we're talking about is installing agents on various hardware devices throughout your network and then storing statistical information about those devices in a management information base, and then using both that database and the SNMP protocol to manage the network both instantaneously and over the longer time periods. Another responsibility of network managers is making sure that traffic loads stay reasonable. And for larger organizations that are providing lots of content to their users, this may require load balancing. Load balancing takes advantage of multiple clusters of servers available to the user that all provide similar information. In order for a user to access one of the servers in the server farm or in the cluster, there have to be smart network devices that direct them to the appropriate available server. So if you look at this diagram, if you were starting from scratch, the first user could be sent to server 1 at the very top. The next user would probably be sent to server 4, which would free up the use of the top switch and instead take advantage of the second switch. And the third user would probably be sent to server 7 in the bottom cluster. And then it would go 2, 5, 8, and then finally 3, 6, 9. And then, once all the servers are being used, you would be directed to the next available server. So your request would be kind of hanging out at the load balancer until a server became available. So directing traffic to the appropriate server in a cluster requires very sophisticated hardware and software called load balancers to make sure that every user's experience is as quick and as efficient as possible. Another possibility for improving user experience is shaping the traffic that flows through your network. Some of this is done through quality of service protocols, which will limit certain types of traffic on the network, especially when the network is busy. So you can see in the bottom right, there's a graph that shows a limitation on bandwidth for a particular user or for a particular protocol. Here on campus, when the network gets particularly busy, often during the very first and last weeks of the semester, our network administrators will shape certain traffic, only allowing the highest level protocol traffic to pass through unobstructed and limiting the amount of bandwidth for things like video streaming or other applications that are not as mission critical. When dealing with access to the internet, a means of reducing the amount of bandwidth that has to leave and re-enter your network would be introducing a content engine or content caching. The idea here is that many of your users probably want to access the same information that's located on the internet, but rather than reach out to the internet, which might take hundreds of milliseconds to get a response, instead a user could first tap a content engine to see if someone else had already requested similar information during a recent time period. And this might be a matter of seconds or minutes, but could even be a longer time period. If someone has previously requested the same information as you and it is cached in the content engine, you can receive that same information from a server that is located much closer to you, and as a consequence, get a response much more quickly. Buffering content in a content engine dramatically improves network performance. Many companies take advantage of this idea of content caching using a content delivery network. And one example of a company that does this is Akamai. If you were located in Asia and you wanted to reach information that is located on a server in California, the first thing that you might do is check to see if a local server, in this case Singapore, has some or all of the information that you'd like to receive. If it's already been buffered locally, you don't actually have to send the HTTP request and response all the way to the west coast of the US. Instead, you could receive much of the content from a local server, which is much, much faster. When you ping various servers in the US for sites that you know are located in particular geographic areas, you may find that your ping suggests that you're reaching a server much closer to you. For instance, when you use Google, which is located on the west coast of California, your server that you're actually pinging is probably someplace closer, like Dallas or Houston if you're here at Texas A&M. That's an example of Google using servers that content cache all of their information much closer to the user so that your user experience is that much better. Network managers are responsible for configuring both the network itself and the clients that connect to that network. So network administrators have to add and delete user accounts as necessary. They have to keep software up to date on client computers and manage how those desktop software systems actually operate. They're also responsible for providing documentation for the overall network, the various components, the software that's running on the network, and how users are configured in terms of their profiles and their access to various network resources. Here is an example of a network administrator would have to be responsible for initially drawing and then maintaining as the network changes over time. You can see that it gives you a diagram of various wiring closets, the appropriate IP addresses for all of the hardware in those wiring closets, the different types of connections between the various devices throughout the building, and some of the hardware itself that's being used in the various closets. For larger organizations, the use of a dedicated network operations center to recognize large-scale patterns and issues that might arise on larger networks. So this picture shows a headquarters for a network operations center. By looking at large patterns, things that might not be obvious when studying a single issue become clear. We might see that patterns arise at certain times of the day, or within certain buildings, or when certain software is being utilized. Analyzing for patterns across the network allows for better troubleshooting and solving of issues. Service management has typically moved to a consolidated help desk model. Again, by aggregating all of the different issues that users are experiencing on the network and collecting them in a central repository, we can come up with the best possible solutions to those problems and recognize if those problems are singular or are systemic. So generating a trouble ticket management software package really helps with tracking problems, collecting statistics on those problems, and prioritizing what needs to be fixed first, second, and third. So you can see here a variety of different tickets that are being highlighted. Some of them are low priority, some are higher priority, and we would even know who's working on various parts of the network at any given moment in time. We can also go back and look through history to see if we've dealt with the problem before and how we solved it, so that we don't have to reinvent the wheel when an issue comes up again. When an issue does occur on a piece of hardware in a network, we have to think about how long it takes to respond and remedy that situation. Many statistics that are reported have to deal with either uptime, how much the network is available, or downtime, when the network is not available, how long until it's back up. But one of the most important statistics that we look at is mean time between failures. How long does it take between each of the individual downtimes? When something does go wrong, the mean time to repair can be broken down into 3 smaller time periods: the time to diagnose, the time to respond, and the time to fix. Generally speaking, the time to respond is manageable by staffing the appropriate amount of people to deal with the issue, and mean time to fix can be limited by keeping equipment fairly standardized, using something like the building block approach for designing your network, and using 1 or 2 vendors for your equipment, and by doing things like automatic replacement. If a computer in a computer lab here on campus has an issue, our technical support, they hot swap that device with another device they know is working properly, and then they can repair the broken device at their leisure in their lab. The largest time period is typically mean time to diagnose. Figuring out what's going wrong is often very time-consuming and challenging, especially as computers get more sophisticated and we use more and more different software packages simultaneously. So time to diagnose is often the most troubling. But if we can do some sort of hot swap for hardware so that the user's downtime is low, then offloading that time to diagnose and time to fix away from the user makes mean time to repair from a user perspective much, much smaller. By collecting lots of statistics on how the network is operating, we can generate things like quality control charts to determine when something is working well or not working well. In this quality control chart, you can see 3 different circuits. Circuit C had an issue that needed to be repaired on period 5, and you can see once it's repaired and tuned properly, that circuit is working great, probably even better than it was before. You can see that circuit B was working well, and then around period 7, it got moved to a new channel and now is performing a bit more poorly. And I would argue that it is being allowed to work poorly much longer than it should be. Probably should be moved back to a different channel. One of the things that's more interesting in this picture is what's going on with circuit A. You can see a slow upward slope from about period 7 all the way to period 12 or 13. Before we ever got to 12 or 13, a network administrator would recognize this pattern and know that something's going wrong with this circuit and address the issue. So what you're seeing for the red line and the green line above that purple area is likely not allowed to continue in the real world. Those would be situations that would be resolved before we actually got to that situation. End user support is one of the most challenging issues for network administrators. Most hardware failures are fairly easy to fix. Sometimes it's just as easy as replacing a piece of faulty equipment, new memory, new hard drive, new monitor. Lack of user knowledge is also fairly easy to fix. We can provide lots of training videos and opportunities to be educated on how best to use equipment and software. The challenge arises when we are dealing with hardware and software working together. Incompatibilities are very challenging. And as the kinds of network uses increase, the opportunity for incompatibilities increase as well. So getting everything to work together all at the same time is obviously a challenge for end user support. The best way to solve most of these issues is with training. As users understand how various parts of the network operate together, the user can sometimes solve their own problems. So user training is one of the most important responsibilities of network management. As I alluded to earlier in this slide deck, managing all of the networks is challenging with any budget, but most network budgets have stayed static or even decreased over time. Network administrators have to deal with cost management. And one of the measures for this is total cost of ownership, which would include the cost of a computer and the cost of all the software that's installed on that computer, plus all of the support staff, training, technical support, and even time wasted when the user can't use their device because of a technical issue. Total cost of ownership for a typical Windows computer could be something between $5,000 and $10,000 for each computer for every year. But the largest component of this is lost time, and some would argue that's not fair. So if we leave out the lost time component, net cost of ownership typically is between $1,500 and $3,500 per computer per year. It's still a very high cost. Anything we can do to reduce this by simplifying the kinds of software we use, using common hardware for different users throughout our network, and keeping things as uniform as possible could dramatically reduce the overall cost of operating a network. The largest cost for any network management is in terms of the people that are using the equipment. The cost of the equipment itself is not particularly all that high. Application software is not that expensive. Network devices, not that expensive. But managing the system, hiring the appropriate staff to deal with troublesome issues, and educating our users is very much the most expensive component of network management. Anything we can do to reduce personnel in terms of automating the system or educating users so that they don't need to access network management support would dramatically reduce overall costs. And these are the areas that get the most attention in terms of improving network performance while keeping costs low. So as I stated earlier, standardization is the name of the game in terms of keeping hardware and software costs low, keeping the configurations as simple as possible, automating as much as possible to reduce the amount of staff necessary, educating our users so that they can troubleshoot their own issues, dealing closely with our vendors so that we can receive pre-installed hardware and software that we know is a proven working model, centralizing help desks so that we can recognize systemic issues and come up with best practices for common problems, and maybe even moving to things like thin clients or cloud-based architectures where we offload some of the responsibilities to a third party would all potentially reduce costs for our network management. Implications for this chapter: network management requires wearing many different hats. You need to have technical understanding and management skills. You need to be able to translate between the technical jargon and the business jargon to make sure that the business decision-making supports the technical needs of the network. You need to be able to manage a network that is increasing in complexity and in use while maintaining or decreasing overall costs. And that means typically having very qualified personnel, but reducing the amount of personnel necessary to manage your network through the use of automation and standardization. That's it for this chapter. Thanks so much for watching. See you next time.